Let's start looking at post-processing. This is the step that you perform after you have solved a system of equations to find properties that are of interest to you, for the specific problem you are solving. Now, this equation should look quite familiar to you by now. So far, we have always been setting up the global stiffness matrix K, find out the loads F, and then applying the boundary conditions to determine the displacements. In other words, we find the displacement at the nodes during processing. This is called the direct result from the simulation. And as you know, we calculate the displacement at the nodes, which is the only information the finite element software has about the structure. Hence, the accuracy of the displacement at these nodes is very high. Now, as you know, we can also post-process the displacements to derive other results, for example, the stress and strain in an element. By manipulating the displacement, you can obtain the strain, and again, another manipulation, the stress. To obtain the strain, you need to use the matrix B, the strain displacement matrix. And depending on how accurate this matrix is, you get a lower accuracy. In other words, every additional manipulation you do makes your result less accurate. Of course, not just whether you are using a direct or derived result is important. As you know, the location of the nodes is very important as well. It is only at these locations that you get an exact result. Of course, node can be shared by multiple elements. That means one node belongs to multiple elements, and the stress and strain are not calculated at the node, but at the element level. Now, of course, it is possible to extrapolate the displacement results such that the stress is not constant in an element, but is actually varying. The weight of the different displacements will be more or less if you get closer to this node. However, the base result is still the displacement at the nodes. When you are interpolating, you are in reality introducing new errors. How this interpolation can be done exactly is something we will discuss in lecture 7. For now, it is sufficient you know that within the finite element software, this interpolation is performed and that it introduces some more errors. When we look at the example on the right, where 4 one-dimensional elements are shown, you see that one node is shared by all 4 elements. In other words, the displacement you calculate for this node has an influence on all 4 elements. And even though the result varies over all elements, this one node will have an influence on all of them. In other words, we are introducing some errors by averaging or interpolating the results at the nodes to the element level. And it are these errors that are key to determine convergence, which is the other topic of today's practical.